Having watched that critic's video all the way through, I was horrified. My eyes were opened to how the developers had supposedly tricked us into buying such a cheap knockoff. According to the critic, the aircraft doesn't turn the way it should. Just look at this chart, they said. How could Eagle Dynamics have been so irresponsible in tuning their flight model? In a rather agitated state, I measured out and drank a full 15 grams of whiskey. My senses sharpened, my vision snapped into focus. And then I noticed something odd about that brown curve, which, in the video, was labeled as the reference at 15,000 feet. The sharp drop in turn rate didn't begin just after Mach 0.8, as you'd expect from transonic aerodynamic effects common to all aircraft of this class, but much, much earlier. Even more bizarrely, the slight flattening of the curve, a signature of the supersonic regime, appeared well before the aircraft had even reached transonic speed. And finally, if you extend the brown line down to the horizontal axis, where turn rate equals 0, in other words, where the aircraft can fly only straight and level, it bottoms out at a meager Mach 1.2. That curve, then, is essentially claiming that the maximum level flight speed at 5 kilometers altitude is Mach 1.2, whereas the well-established power available versus power required charts in practical aerodynamics clearly show the true figure to be around Mach 1.7. Taken together, it's hard to avoid the conclusion that the author of that video simply botched the speed conversion on the chart and didn't even spot the obvious mistake. Or rather, he did notice the glaring discrepancy between the MiG-29 and F-16 curves, but chose to explain it away with talk of pathetic Soviet aerodynamics. In reality, as even an undergraduate student can see, the real culprit was nothing more exotic than an incorrect conversion of IAS into TAS and Mach, with compressibility duly accounted for. As I've said before, testing someone else's work is a fascinating business. And when the module costs what it does, it's worth doing properly. That's why, preparing for my own testing, I carefully digitized the turn time charts from practical aerodynamics and converted the indicated airspeeds on the horizontal axis correctly. And lo and behold, the genuine MiG-29 curves do indeed level out near Mach 1.7 at 5 kilometers and near Mach 1.15 at 1 kilometer. Cross-checking against the specific excess power charts confirms the same. Overlay the curves, and the picture speaks for itself. Notice how the authentic MiG-29 graph resembles that of the F-16. Of course it does. The laws of aerodynamics are the same for both aircraft. A few words about the quality of the testing itself. First, the fuel load. The rate of turn is quite sensitive to aircraft mass, yet for some reason the test assumed a rather adventurous 90% fuel, while the reference documents clearly specify 1,500 kilograms, about 50%. Second, those strange bumps and dips on the experimental curve. I sincerely doubt Eagle Dynamics developers would allow such artifacts into their FM, especially given that I've already seen forum test results from other authors, both for this and other ED aircraft carried out with external autopilots, and none of those showed such artifacts. So, I must admit, a weight has been lifted from my heart. Perhaps the module is not nearly as bad as that video would have us believe. My trust in those pale green dotted lines has evaporated. Measuring the limiting sustained turn rate manually is not a trivial exercise. It demands a high degree of skill, At the very least, a quarter circle flown with a steady altitude, constant speed, zero vertical velocity, and stable G-loading. Not an easy task. So, I've decided not to gamble. The whiskey cabinet is locked, and I'll be drilling sustained turns properly, figuring out a rigorous way to process the data, perhaps even with that elusive Lua export, because, unlike some, I'd rather not squander my reputation on sloppy trials and diagrams that look more at home in political rhetoric than in aerospace engineering.